Welcome to lesson 12.2. In this lesson, we're going to talk about solids of revolution right here. So let's start by defining this. A solid of revolution is a three-dimensional object formed by spinning a two-dimensional figure about an axis. So I actually have some visual aids. So think about this. I have this cute little turkey here. He's very much a flat turkey. However, I can take this two-dimensional flat object and I can rotate it around, revolve it, solid of revolution, and now I get this 3D object that I formed. That's a solid of revolution, where you take a 2D flat object, you spin it around, and you get a 3D object. Now, notice this 3D object. What shape do you see a lot of in this object? Well, we see a lot of circles because we're revolving. We're taking one shape and we're spinning it, and that gives us a lot of circles. This is important to know. For this entire lesson, we are not talking about things like cubes or pyramids or things like that, because those shapes are not curvy. This whole lesson is about revolving things, which gives us curvy shapes like spheres and cylinders and cones and a couple others that we'll talk about. Those are the kind of shapes that we're talking about. Curvy shapes that have circles from revolving around an axis. So, let's introduce this here. In number one, we have a solid of revolution. We have this triangle right here. And it says we want to rotate this object around the x-axis. So, I actually have another visual aid right here. I have this triangle. It's on a straw axis, just like that picture. And I want to take this triangle and I want to rotate it around the x-axis. I want to rotate it this way. So if I start rotating and spinning that faster and faster and faster, we can start to see what shape that's going to make us. If I take this triangle and I spin it all the way around, it's going to give me a cone. Hopefully you can start to visualize that. So we know that this is going to be a cone. Now another way that you can visualize this, we have two steps that we can do to draw these shapes and help us visualize what the shape is. So the first step is to reflect the shape across the axis. So this one is the x-axis, that's what it tells us. So I'm going to take this triangle and reflect it across the x-axis, because that's what it told me, the axis I was thinking of. So I reflected the shape across the axis. And then number two, this is kind of weird. I am going to draw small, actually, let me use a different word for that. I'm going to draw skinny ovals over perpendicular lines. So in this one, I'm going to emphasize the axis that I'm rotating around, and any lines that are perpendicular to that axis, I'm going to draw skinny ovals on. So I have this line is perpendicular to that axis. So I'm going to take that line and I'm going to draw a skinny oval around it. I got my skinny oval around that line. And right away you can start to see our cone shape. That skinny oval makes that cone kind of look 3D, kind of come to life. So there, I've now drawn my cone shape. Now, number 2, it says, find the volume of the solid formed. So the first thing we need to know is the equation for volume of a cone. And this is one you will want to memorize and have in your head. If I want the volume of a cone is actually 1/3 pi r squared h. That is the equation for volume of a cone, and that is one you will want to memorize. So all I need to know is what r is and what h is. Well, r is going to be half of my skinny oval. That's r. Radius is half of the circle, half of the skinny oval. So I come over here, find my skinny oval. Right there, there's my radius, and it looks like it's 2. So my radius is 2, and your height is perpendicular to the skinny oval. So here's my skinny oval. I want perpendicular to it, so right there, that is going to be my height, and it looks like that is 4. And now I just need to plug it in. So volume of a cone is going to be 1/3 pi. R is 2, so 2 squared times h is 4. 2 squared is 4 times another 4 is 16 times 1/3 is 16/3 pi. You could also just type all this into your calculator and see what you get, but I'm totally fine if you just leave it like that. You don't need to type it in. So that is our very first example of revolving a solid around an axis and seeing what we get. In the next video, we'll do some more examples where we continue to visualize what this all looks like and how to find the volume of these objects.